Hello, welcome to the lecture series on Control Systems Engineering. In the last session, we were discussing about Nyquist plot. So we'll continue our discussion with some more examples, right? So now, I have another problem. As I say, it is a type 1 problem. There are two poles. Yes, we have 4 here. As I said, the Nyquist path, you take S-plane, mark the pole at the origin, and complete this Nyquist path, and divide this into 4 parts. From here to here it is 1, this semicircle is 2, this is 3, and this semicircle is 4. Okay, first we will draw the Nyquist plot of section 2. Okay, as I said, any point on the semicircle we can represent by a phasor. S is equal to epsilon e to the power of j theta. It represents magnitude, it represents angle. Theta varies from plus 90 to minus 90. Yes. And epsilon is tending to 0. Then we will substitute that value into this. Then you will get g of s, h of s. Here compared to 1, epsilon is very small. I ignore this, I ignore this. Then it will become 4 by epsilon e to the power of j theta. 4 by 0 e to the power of minus j theta. 4 by 0 is infinity. E to the power of minus j theta. Theta plus 90 to minus 90, when I substitute, it will become minus 90 to plus 90. And the circle 4 by 0, the radius will be infinity. So when you draw the Nyquist plot for section 2, you will get a semicircle of infinity radius like this on GH plane. Okay, on GH plane. Okay, counterclockwise direction. Then let us talk about next how to draw Nyquist path for section 4. It is, let us say S equal to REJ5. Correct? R is tending to infinity, phi varies from minus 90 to plus 90. Again you substitute into g of s, h of s. Compared to r, this is small, ignore. Then r cube. Okay. j5, e3, j5. Substituting the limit r tending to infinity. Okay. R tending to infinity. Then finally it will plot into a circle of 0 radius and phi varying from plus 270 degree to minus 270 degree. Then totally 540 degree it should cover. So you know it is 0, 90, 180, 270. Okay. Again minus 90, minus 180, minus 270. It starts at plus 270. Correct? Right, like this. 540 degree I have to cover. I have covered 360 degree. Ends at minus 270 degree. That's how it is. Okay. Oh, sorry. Sometimes why I make that kind of mistakes, I don't know. Plus 270 like this. Yeah. Correct? Counterclockwise, totally 540 degree. Okay, right. This is how section 4 gets plotted. It is of very small radius. Later we'll make it a point. Next, for section 1, I'll draw the polar plot. So you have drawn the polar plot. You know how to draw the polar plot, and let us say this is the polar plot of it. Mirror image, section 3 is the mirror image of the polar plot. Fine. Now we have got all the sections. Okay. Now, before drawing the Nyquist plot, when you have drawn the polar plot, it has cut the negative real axis at this point. What is that value? We have to find out. Okay, to find that value, rationalize this thing. For yes, you write yes, 1 plus 0.1 is 1 minus 1 plus 0.2 is 1 minus 0.2 is. Same thing you repeat. Okay, then you multiply. Substitute s is equal to j omega. Correct. Then you separate that into real and imaginary parts. This is the real part, this is the imaginary part. Equate the imaginary part to 0. If you equate the imaginary part to 0, you will get omega equal to root 50. It will intersect at omega equal to root 50. You substitute this value here. Correct. In the real part, you will get 0.267. So that value is 0.267. This value. Okay. Minus 0.267. Okay. Now I have everything. I can draw the plot. If you see, this is, you write GH plane. This you call it as real. This you call it as imaginary. So minus 92 plus 90. Okay, I'm not drawn it properly. Sorry for that. Minus 92 plus 90. Then you have plus 272 minus 270. This is your section 4. Okay. Then you have your polar plot. Okay. Mirror image of the polar plot. Okay. So continue this arrow. That is important, right? You'll get the plot. This is circle of 0 radius, no? Finally make it a point like this. Okay, that's how you get the final plot. This value is minus 0.267. Your minus 1 plus j0 lies here. And if you see the problem, no open loop pole is on right hand side. So no closed loop pole is also on right hand side of S plane. And if you draw number of ends, it is not at all encircled. So you can say 0. So z suffix minus 1 is p suffix minus 1 plus n suffix minus 1. So it is 0. System is stable. No closed loop 0 is on right hand side of S plane. Okay. Right. This is the. Now, the same problem, what I'm going to do is I have taken 100 here instead of 4. Okay. So again you draw the Nyquist path. Then divide this into section 1, section 2, section 3, section 4. Draw root locus plot for section 2. Then draw root locus plot for section 4. Then polar plot for 1. Mirror image of the polar plot for 3. Right? Then you have to find out intersection point. Okay? This is analysis of section 2. Then polar plot section 1. Mirror image section 4. Then real and imaginary part you do. You get omega is equal to root 50. Substituting in the real part, you are going to get 6.67 minus. Right. Now here you have minus 6.67. So your minus 1 plus j0 is here. No pole is on right hand side. Correct. But there are two encirclements. n suffix minus 1 equal to 2. So z suffix minus 1 is 2. So system is unstable. So when you increase the gain, system becomes unstable. Right? Two zeros are on the right hand side of S plane. Okay? Very interesting problem you see here now. K S minus 1 divided by S into S plus 1. You have to do it little carefully here. Okay? Because there is a minus sign here. Again you draw the Nyquist path as it is. Now section 2 you take. You know section 2 is S equal to epsilon e to the power of j theta. Substitute into this. Limit S tending to epsilon tending to 0. Correct? So here K epsilon e to the power of g theta minus 1 epsilon e to the power of j theta epsilon e to the power of j theta plus 1. Compared to this is small. Compared to this is small. Whole thing is you are going to get minus k by 0 minus infinity. So minus means it has shifted by 180 degree. So that is the reason here you have to write this k by 0 is infinity epsilon e to the power of minus. This minus sign you have to take care by adding plus pi 180 degree. That's the one thing you need to be careful about it. Okay, this I have explained in polar plot. How exactly the position of the pole changes that angle. Right. Now theta is plus 90. Plus 90 to minus plus 90 plus 180 minus 270. Then minus 90 plus 180 minus 90. Totally 180 degree. Okay, so you have to draw minus 270 degree to minus 90 degree. Correct? And it should go, here it is clockwise, it should go in counterclockwise direction. Correct? So the plot will be minus 270 it should start. Correct? Okay, let me draw this here. Real GH, imaginary GH. So it is minus 270 is here. It should start minus 270, go in the counterclockwise direction and stop at minus 90. Total difference is 180 degree. Okay. So because of this minus 1, you can see here it has shifted this way. Section 2. Okay. Now you draw the Nyquist plot for section 4. Section 4, when you draw this, when you substitute over here, this minus will not affect. Correct? So this will become k by 1 will cancel with 1, k by r, that is k by infinity 0, e to the power of minus j5 you get. So minus 90 means it is plus 90, it is minus 90. Okay, now plus 90 to minus 90, clockwise direction. Plus 90 to minus 90, clockwise direction. Next you draw the polar plot. Polar plot is comes in this fashion. Okay. Then mirror image of the polar plot. It comes like this. Okay. Now continue the arrow. Continue the arrow. Of course, later you make it 0. It is 0 radius. Yeah. Then you will get the plot you desire. This one. Minus 1 plus j0 is here. No open loop pole on right hand side. Number of encirclement 0, 1. Correct? So 1 0 is on right hand side of S. Of course, one open loop 0 is also on the right hand side, and one closed loop 0 is also on right hand side. System is unstable. So here Ks plus 3 divided by S into S minus 1. I have given S minus 1 here in the pole. So again it will create the same problem. Okay, you will get infinity e to the power of minus j theta plus pi, 180 degree it will shift. That's how the angle will be minus 272 minus 90. Be careful about these things. Then you draw the polar plot. You will be getting the polar plot like this, of course. Then section 4, fine, you draw all these things and find intersection point, it will become minus k. Okay, minus k. You want system to be stable, correct now? So we can easily find out if at all the k value is such that, suppose k value is minus 2, then definitely minus 1 will be here. K value is less than minus 1, then minus 1 plus j0 will be here. So what I have done is a minus k is less than minus 1, that is k greater than 1. So one pole is on right hand side, correct now? And see the encirclement. K greater than 1 means there are two clockwise, one counterclockwise. So it's going to be minus 1. So z suffix minus 1 is p, n suffix minus 1 is minus 1. So z suffix minus 1 is 0. System is stable for k greater than 1. By chance k is less than 1, correct? K is less than 1, then what you can say here, your minus 1 plus j0 is here. If I draw, there is only one counterclockwise. P suffix minus 1 1 counterclockwise. There will be two zeros on right hand side. So closed loop system will become unstable. Okay. Hope you have understood this. This kind of tricky problems you should be a little careful, right? So that is why for practice I have given these kind of examples. You please work out, right? Okay. So I think I have made clear with the drawing, by drawing this Nyquist plot for type 1 problems. In the next session, let us draw for type 2 systems the Nyquist plot. The procedure is same. Only thing is you have to patiently solve these problems. Okay. Thank you very much.